How are you? I hope you are doing fine. Today I want us to look at the angle in the alternate segment, still under the topic circles, chords, and tangents. So if I draw a circle like the one you can see I've put on the board, and then I have a tangent. Let me call this tangent ABC. So tangent ABC, tangent AC is touching, or it is in touch with the circle whose center is O at point B. Now if I draw a line, let me say this is a line BD, then I can also conclude that BD is a chord. Remember we covered chords earlier on. So this chord has divided this circle into two segments. We have the first segment, which I can shade like this, and we have the unshaded segment. So this segment, this chord forms an angle with the tangent. Let me call this angle theta. So this angle is an alternate to the segment A. Let me say this is K, BKD. PKD is a major segment, and BLD is a minor segment. So the angle theta is an alternate angle to the segment BKD. At the same time, the angle ABD is an alternate angle to the segment BLD. Now I want to introduce other properties. So we have a circle, and then I have a tangent. Let me say this is A, B, and C again. So we have tangent AC meeting the circle at point B, and then we have BD as the chord. Now, if chord BD forms an angle at the circumference of the circle, let's call this Y. We call this angle Y. We may introduce the center O there. Then we draw a straight line to join B from the center and the circumference of this circle. So let me call this E. Now, because it has gone, this OB is joining the tangent AC at B. This angle here is 90 degrees. The angle there is 90 degrees. Now, let me call this part here M, this angle EBD, M, and then I call this angle DBC, let me call it N. Now, if I still use this same chord and I join E to D, from the previous properties, we learned that angles subtended by the same chord at the circumference are equal. Therefore, this angle BED is equal to angle B, let me call this F, BFD. So this angle, which is Y, is also going to be equal to Y. Now, BD is, of course, a diameter. Also, from our previous lessons, we mentioned that an angle subtended at the circumference by a diameter is 90 degrees. An angle subtended by the diameter at the circumference of a circle is 90 degrees. Therefore, because of the rule of adding all the angles within a circle, a triangle will bring us 180. Therefore, it implies that Y plus M equals to 90 degrees. Because this is 90 degrees, then these two angles, M and Y and M, their sum is 90 degrees. At the same time, we can say, because this EBC forms 90 degrees, then consequently we can say that N plus M is also equal to 90 degrees. Now, because 90 degrees equals to 90 degrees, then it means that Y plus M equals to N plus M. And if we subtract M from both sides, we are going to see that Y is equals to N. Therefore, we can conclude that an angle subtended by a chord is equal to the alternate angle. Therefore, we say that N equals to Y. Therefore, we have been able to prove that this angle N equals to angle Y. Now, we want to take an example. So in our example, the question reads, in the figure below, angle DCF is 50 degrees and angle ACB is 40 degrees. Find angle BCE and angle ABC given that EF is a tangent at C. So this is a tangent EF at C. So we are going to, first of all, you can check the angle. You say angle DCF is equal to angle CAD. Reason being, this is an alternate angle, so equals to 50 degrees. Then, because this triangle, this is an isosceles triangle, because AC equals to AD, then it means that if we have this as 50 degrees, this is going to be 65 degrees. That is, you subtract 50 from 180, then you divide by 2, you get this is 65 degrees. Now, because I've got, this is a straight line, this is 50 degrees, this is 65 degrees, and this is 40 degrees, angles on a straight line add up to 180 degrees. Therefore, angle BCE equals to 180 degrees minus the sum of all these angles, 40 plus 65 plus 50, which is going to give us 25 degrees. So that's how you should be able to apply those properties. Now, I want to give you some work from KLB. KLB Book 3, Exercise 7.6, answer question or number 1 and number 4. Have a nice time.